Hello Geometry, this lesson is titled Measuring Angles. On this lesson we're going to start out with a lot of vocabulary, so bear with me here, but this is very foundational stuff. So the first word we have is angle. What is an angle? Well, an angle is formed by two rays sharing an endpoint. So what does that look like? Again, we have a ray, and then that endpoint is also extending from another ray. Okay, so when two rays join together with the same endpoint, what gets formed here is an angle. Okay, now we're going to be dealing with tons of angles, so get used to that. Now, what is the vertex of an angle? Well, the vertex of an angle is the endpoint of the two rays. So again, I'll draw this up here. Okay, so here goes our angle. Okay. The vertex is right here, so it is the endpoint. That's what it is. The vertex is the endpoint of the two rays that create this angle here. Okay? Alright, so that is what a vertex of an angle is. Now, the question is, what are the different types of angles? Well, first, by measurement, we have an acute angle. An acute angle is an angle less than 90 degrees. Okay? So, an angle less than 90 degrees, and we're going to draw a lot of these throughout our time, so we'll do a little diagram later, but just a really quick one. This is kind of a picture of an acute angle looks like. Okay, now a right angle, or what is a right angle? A right angle is an angle that is 90 degrees. So 90 degrees basically makes like an L. Oops, sorry about that. Basically makes like an L, so this is what a right angle is. So therefore, that's why an acute one looks the way it does, because it's less than that right angle right there. Okay? So here we have an acute angle is less than 90 degrees, a right angle is 90 degrees, so therefore, by process of elimination, an obtuse angle is an angle greater than 90 degrees, but less than 180. Okay? So a picture of that would be something like this. So it's greater than 90, but it is important to know that it is less than 180 degrees, because an angle that is 180 degrees is called a straight angle. Okay, a straight angle is an angle that is 180 degrees. Basically what that is it makes up a line. So a line technically is a 180 degree angle. Okay, so we have acute, which is less than 90 degrees, right angle is 90 degrees, and obtuse is greater than 90 degrees, but less than 180, and then a straight angle is 180 degrees. Okay? Now next here we have congruent angles. What are congruent angles? Well, congruent angles are angles that have the same degree measure. So, if two angles are both 60 degrees, then we would say that they are congruent to each other, since they have the same degree measure. And again, we're going to get a lot into that later. Next thing is vertical angles. Vertical angles are formed at the intersection, that's supposed to say at the intersection of two lines or segments. So the picture of that is if you had two lines intersecting. Okay, this angle that gets created here and the one that's on the opposite side of that intersection. So again, it's the angle that's on the opposite side of that intersection. Those are vertical angles to each other. In like manner, if this angle on the left would be vertical to the angle over here on the right. Now, what we're going to learn later, well, you're going to hear it now, but we're going to definitely go into later, is that vertical angles are always congruent to each other. So if this is 120 degrees, we know that this one is 120 degrees down here as well. If this is 60 degrees right here on the right, we know that this is 60 degrees on the left, because vertical angles are always going to be congruent to each other. Okay? Alright. Now the question is, what are adjacent angles? Well, adjacent angles are angles that share a ray and an endpoint. So if I have an angle like this, that's just two rays. Now if I were to extend another one using that same ray, then this angle right here and this angle right here would be adjacent angles to each other because they share the same ray and they share the endpoint. Now it's important to specify that they share an endpoint as well, because what we could technically draw that would not be adjacent angles would look like this. Notice here, this endpoint is not, or they're sharing this endpoint, but this one actually extends back down to this endpoint. So this is not an example of adjacent angles. Again, they need to share a ray and they need to share an endpoint. Okay? The same endpoint. Okay, two more words here. The next one is complementary angles. What are complementary angles? Complementary angles are angles whose measures add up to 90 degrees. So what we learned about a 90-degree angle is a right angle. So what we can say is basically the two angles, they would add up to create a right angle. So here's an example of complementary angles. This angle right here and this angle right here, since they add up to what we say a right angle, this is a symbol for a right angle, these two angles right here and here would be complementary to each other. Complementary angles are angles whose measures add up to 90 degrees. Well, next we have supplementary. This is our last vocab word. Supplementary angles, they are angles whose measures add up to 180 degrees. Now again, like we said before, 180 degrees creates a line. So a picture of this would look like that. We have this angle right here, this acute angle, and this obtuse angle. When we put them together, they create a straight line. Okay, they create this straight line. So therefore, these two angles right here, that's an example of supplementary angles. Okay? Alright, let's move on. How to name angles. How do you properly name angles? Well, the way to do it, there's a couple ways to do it, but the main way is to use three letters. Okay? If I want to go ahead and name this angle, because we're going to have to name all the angles in the diagram. If I want to name this angle right here, I have to use the three letters that are connected to the rays and the vertex. But it's very, 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 very vital that the vertex is the middle letter. So the way we would label that is we would say angle, we use the angle symbol, angle A, D, B, because D is the vertex. Okay? Now we cannot just say angle D right in this situation, because what are we talking about? We have actually 1, 2, 3 different angles that include D as the vertex. So you can't just use one letter if there's multiple angles created with the same vertex. Okay? So we have the yellow one, which is angle ADB. And it doesn't matter if you start with A or B, as long as D is in the middle. So we could have also said angle BDA. Okay, that's the same thing. Okay? Now we have the orange one at the bottom. We would say angle BDC, or again, vice versa, or we could say angle CDB. And lastly, we have the blue one. We could say angle ADC, or flip it around, CDA. Notice, again, D is in the middle of all of them, because that is the vertex. When you use three letters, you have to have the vertex as your middle letter. It's extremely important. We always use the angle symbol out in front as well. Okay? Let's go ahead and move on. Alright, now here's a very, very important postulate. It's called the angle addition postulate. What this is actually saying, in my own words, is that if I take this measurement of this angle and I add it to this measurement of this angle, it gives me the whole angle. Okay? Little angle plus little angle equals the entire angle. Okay? And also, if it ends up being a straight line, it's going to add up to 180. That's what this one is saying. If I take this one and I add it to this one, and it creates a straight line, we know it's going to be 180 degrees. So let's do a little, we're going to throw in some numbers here. This first one says the measurement, that little m, by the way, we use the m when we actually know the number value, or the degree measure, the specific degree measure. So that little m stands for measurement, okay? I want to make that note. That stands for the measurement. So the measurement of angle TSW, this one right here. We're looking for that one. Sorry, we're looking for that measurement. What is the measurement of angle TSW if angle RST, this one right here, I'll do that one in blue, is 50 degrees. Okay? And we know that RSW, so the entire angle is 125. So what we can say is we know the 50, the small angle. The other angle we don't know, the measurement of angle TSW, equals the angle, the entire angle, which we do know is 125. And here now it just comes down to some basic algebra steps to get this by itself. Well, what we would do is we'd move that 50 by subtracting. Okay? And we would be left with the measurement of angle TSW is equal to 75 degrees. Okay? 75 plus 50 equals 125. But this is what our answer would be for this problem. Okay? Small angle plus small angle equals the entire angle. Now this one says, if we know that DEG, so from here all the way to here, is 145, what is GEF? Now it only gave us one degree measure. Notice on this one up here, it gave us two. It gave us the 50, it gave us the 125. This, all it gives us is 145. Well, we can still solve this because, again, this is a straight line. So we know that 145 plus the measurement of angle GEF, sorry about the handwriting, is equal to 180 degrees. So again, we subtract 145 from both sides, okay, to cancel that out. So our answer is the measurement of angle GEF is equal to 35 degrees. Okay? So again, we know the 145, but we also know the straight line is 180. So we just do 180 minus 145 gives us 35 degrees for this acute angle right here. Okay? Again, this is the angle addition postulate. Small angle plus small angle equals big angle. Okay? Now let's talk about what these kind of look like again in specific. I know I already went over it with the definitions, but I still want to just reiterate. Vertical angles, again, types of pairs. Vertical angles, again, get created by the intersection of two lines or segments, and they're on opposite sides of those segments. So these two would be congruent to each other. The yellow ones would be congruent to each other on opposite sides of the intersection. Okay? Again, adjacent angles, if you have one angle, but then there's another ray extending from that same vertex. These two angles right here, this yellow and this blue one, those would be considered adjacent angles because they share the same ray and they share the same vertex. Right? Complementary angles, again, what does that look like? They add up to 90 degrees. They create a right angle. So this would be an example of a pair of complementary angles. Because they create, and this is the symbol for right angles, a right angle. Okay? Supplementary, again, creates a straight line. So if you have a straight line and a ray anywhere on that line, extending from it, it creates this angle, and this angle would be supplementary. Okay? They add up to 180. Alright, we're almost done. Here we go. Specific symbols. Just to reiterate what symbols that you're going to see, we all know the equal sign. Oops, sorry. Wow. We all know the equal sign. Congruent. If you're talking about two things being congruent, okay, we don't know the necessarily the number value. You're just told that one figure is congruent to it. The next, we make this symbol right here. It looks like the equal, but it has the little squiggly line or the tilde above it. Okay, that's the symbol for congruent. Parallel, again, looks like 11. Okay, that means parallel. So if I say one line is parallel to the other, that's what I would put in between. Perpendicular means it creates a right angle. And the symbol you would see for that looks like this. Again, perpendicular means the intersection is a right angle, okay, of two lines or two segments. So here's our last thing we're going to do. Identify pairs of numbered angles that are related as follows. Complementary angles. Okay, can we find two angles that are complementary? Again, the thing I said about complementary is that they add up to 90 degrees. So we look for that 90 degree symbol, that right angle symbol. And notice angle 3 and angle 2 make up the right angle. And here we're not given points, so we can't use letters to name the angles. If they ever give you numbers like this, the 1, 2, 3, 4, 5, you can just use those to name the angles as well. Angle 1, angle 2, angle 3, and so on. Now we need to identify a pair of supplementary angles. Again, supplementary angles form a line. So the best way to find supplementary angles is look for an entire line. Well, as it's depicted. So here, I see that line, and I see that here's a ray coming from that. Well, the two angles I see that form that are angle 3 and angle 4. Okay, so that's an example of supplementary angles. And lastly, we have vertical angles. And again, the best thing to do is look for the intersection of two lines. So here goes a line, and here goes a line. So on opposite sides of that intersection, you're going to find vertical angles. So an example would be angle 5 and angle 3. That would be a pair of vertical angles. Okay, so this lesson is all about angles, supplementary, complementary, obtuse, acute, all that stuff. So I hope this helped you understand a little more. Oh, we actually do have one more example. Sorry about that. What can you conclude from the information in the diagram? It's actually important that I saw this because I want to explain that these marks right here, when it gives you the same number of marks, notice it's one mark here on the 2, one mark on the 1. That means those are congruent. So we could say that angle 2 is congruent to angle 1. Again, if they ever have the same amount of marks, those little pink or red marks right there, that means they are congruent. Okay? Clean that up a little bit. What else can we say? Well, think about the things that we've just learned. We just learned about supplementary angles. Here goes a line. Here goes a ray extending from that. So we can go ahead and say, because of that, we can say angle 4 and angle 5 are supplementary. That's something we can conclude. We can also conclude, if I were to extend this past there, we could see vertical angles here. So angle 4 and angle 1 would be congruent because they're vertical angles. Okay? So just some things that you conclude. We can conclude more things, but these are just some examples from that. So thank you for enduring through this video, and I hope this will help you to be able to understand the things that we're going to go over in the future. Alright, good luck.